Okay, this is the point where I think things get a little bit different than what you've done in geometry, when we start looking at trigonometry being extended to circular functions. And so the first thing I want to remind you is, if we look in the four quadrants, the standard first quadrant is number 1, and that's where we would be up in the upper right. And then we have quadrant 2, 3, and 4. And so the first questions ask you things about an angle being coterminal. So if I was coterminal with, say, 60 degrees, co means together and terminal ends, I want other angles that end in the same place. So this is the standard position. To start here is 0 degrees along the x-axis going out to the right. If I decided to go in a negative direction, what would be coterminal with 60? Well, if the whole thing is 360, but I didn't go that final 60, I could say that negative 300 degrees is coterminal with 60. Or I could say 60 plus 360, or 420 degrees is coterminal with 60 degrees. Of course, all this can be done in terms with radians also. So I could call this pi over 3. And then if a whole circle is 2 pi, then I could say 2 pi plus pi over 3, which would end up being 7 pi over 3. That in radians would be coterminal angles. So it's important to understand what it means to be coterminal just start. And of course you can go in either direction. You can do as many circles as you want. So I could do 6 pi plus pi over 3. That would be 3 full circles, but I would still end up in the same place. So if I did 6 pi plus pi over 3, I would end up with 19 pi over 3. This, and this are all coterminal angles. Okay? So why does this matter? Because basically we're going to use this to extend the trig functions to understand if I have sine, cosine, or tangent of an angle that is not an acute angle. So let me just, for the sake of argument, put a point out here at, let's say, 4, 1. If I have my standard initial side right here, and my terminal side, or the side where I am going through there, I could set up a right triangle where I have this side is equal to 4, the side that's perpendicular to it is equal to 1, and I could use Pythagorean theorem to get that c is going to be the square root of 17. If this is the angle that I have in question, always the angle between the x-axis and your terminal side, I could now find all of the basic trig functions. Sine would be 1 over the square root of 17. Cosine would be 4 over the square root of 17. Tangent would be 1/4. Cotangent would be 4 over 1. Secant, which is the reciprocal of sine, would be square root of 17 over 1. And cosecant, and secant is the reciprocal of cosine, so I'd have square root of 17 over 4. I always remember that each pair has a co. So sine and cosecant, cosine and secant, and then tangent and cotangent. So each one's going to have a co. So what happens now if I extend this into a different quadrant? Say I tell you the terminal side goes through negative 2, 3. Well, I'm going to go over 2 and up 3. That's how I'm going to draw my triangle. Notice I always draw my triangle where one side is the x-axis. Okay, so I've gone over 2, I'm up 3. Again, with Pythagorean theorem, I can figure out that that's the square root of 13. So what's the sine? I'm sorry, this should be negative because it shows that I'm going to the left. The sine of the angle that got me there, really we almost want to treat that like the angle in here. Sine will be opposite over hypotenuse. The cosine, in this case, in the second quadrant, would be negative. It would be negative 2 over the square root of 13. The tangent would be opposite over adjacent. Okay? And we could do the same with secant, cosecant, cotangent. So the important thing to remember here is my triangle, if I had really drawn the angle properly, kind of looks like that. But in order to make it into a right triangle, I go through here and I kind of have this idea of my angle being between the x-axis and the terminal side. Okay, that's going to make all the difference in the world. So that's something that's important to understand. We'll do some examples of that in class.